This is a quick demonstration of some of the new QuadPlane features in Plane 4.1. So I haven't actually released the first beta of 4.1 yet, but I will be doing that fairly shortly. So this is just a preview, and also it's a bit of a call for early testers to start trying it and to see whether they can find any issues with it. So most of these changes are going to be in and around the QuadPlane landing code. So what I've got here is a Griffin and a race Griffin quadplane, a tilt rotor, so the front two rotors tilt for forward thrust, and the rear two rotors are fixed. And I've got a mission set up, and this mission is a little bit different than what you would have used for 4.0. In particular, if you notice this waypoint here, this is the waypoint that is the VTOL land waypoint. Now, this is the one that in plane 4.0, when it hits that waypoint for coming into landing, it would immediately transition to VTOL flight and raise the rotors, and then it would crawl slowly towards this landing position. The big difference in 4.1 is this waypoint can be as far away from the landing point as you like, and it will actually continue in fixed wing flight until, based on the wind conditions and the ground speed and the tuning of the aircraft, it picks the right point to transition to VTOL flight for a correct slowdown and landing. It basically makes it a lot more efficient, and it means you don't have to adjust the mission based on the wind conditions and your expected speeds, etc. And the same thing applies to the QRTL command. So I'll just give you a demonstration of that. So what we're going to do is we're going to just restart the mission, make sure it's in auto mode, and I'm going to then arm the vehicle, and it will take off and start flying this little mission. And the interesting part happens when it starts coming around to this point here, where it would normally transition. So this is just the normal flight. There are a number of smaller improvements in the normal fixed wing flight of ArduPilot, and there's also improvements in the transition and the other back transition code. There's been a lot of under the hood changes that improve the quadplane performance. But the really noticeable one, and the one you need to know about when you're planning missions, is what's just about to happen here. Now, if this was 4.0, then it would have transitioned by now, but you can see it's still flying as a fixed wing vehicle, and then it picks just the right point when it's coming up to the right distance to be able to slow down, and then it then switches to VTOL mode, and it'll then make its way to hover just above the landing waypoint and start to descend. Now this is where the next trick comes in. I've just paused the descent. Now that's something you can't do in the 4.0 code. What I've done is there's a special option in the Q options. You have to enable this capability. It's not on by default. The transition approach code is on by default, though you can turn it off. And this pause code is something you have to enable. I've enabled it in this setup. And what it does is if you enable this feature, then if I hold up my transmitter here, you'll be able to see what I'm doing. So I've got the throttle stick here, and if I move the throttle stick down, it'll start descending. If I bring it halfway, it pauses. And if I raise that throttle stick, it'll actually start climbing again, which means that I can actually pause the descent of the vehicle, and while it's paused, I can reposition it. So for example, I can make it move a little bit to the left like this. And what it's doing now, I'm just holding over the roll stick here to the left, and the plane is now repositioning for the perfect landing. This is very helpful if, for example, your GPS is off by a few meters and you want to touch down perfectly on the landing pad in just the right spot. You can, of course, move it forward and backwards as well. So here I am moving it forward a little bit, and it's a little bit zoomed in, a bit far there, so it's a bit harder, you're not seeing it very well. But basically you can move it forward and move it backwards, and it'll reposition itself. You can, of course, just like you could in 4.0, you can yaw it. You notice I've yawed it round there using the yaw stick like that. And and then you can, to complete the landing, you just lower the throttle and it'll descend for landing in that current position. And it does do the automatic slowdown. So if the throttle stick gives you a proportion of descent rate based on the descent rate that it wants for the current height above the ground. So when it's close to the ground, then fully down is a slow descent. When it's higher up of the ground, then fully down is a faster descent. And then you can climb it back up again like that. If you've decided, for example, to abort, you might make it climb back up and then change it to a different mode, say fly-by-wire A or cruise mode or whatever, which allows you to do a manual abort. All right, so I'll let it do a full landing now. The poor little thing's been hanging around for a bit long there. So now it's going to do a landing, and it does a slow landing because it's got into its final landing phase, and it'll do a neat little touchdown there. Okay, so that's the new features for autonomous missions. So we can now we don't need to set up the waypoint precisely for the auto mission. It will now work it out itself where it should start the back transition, which is a real battery saver, and also much easier to plan the missions. And we can now optionally slow the descent or start climbing back up again. Okay, so let's go to the next feature. So what I'm going to do is I'm going to do something more of a manual flight. So I'm going to put it into, say, Q loiter mode, and then I will arm the vehicle, and then I'll just raise the throttle stick here and tell it to take off. And it's still actually, I didn't do set mode. All right, now I'll set mode and I'll tell it to take off. And now once it's gained a little bit of height, I will, it's up to like 20 meters or so, which is probably above the local buildings there. I'll pop it into cruise mode and will transition out into cruise mode and let it fly around a little bit. Okay, so it's now flying about in cruise mode. So we're doing a long distance flight here and having fun with our aircraft. And then we want to bring it home. All right, I'm going to make it auto pan so it tracks the aircraft over there. And so it's gone off way into the distance. And what I'm going to do is I'll put it into QRTL mode like that. All right, so it's now in QRTL mode. Now what's happening is it's actually flying in fixed wing mode because it's beyond the distance it needs for back transitioning. So instead of going straight into the VTOL mode and a slow transition back, it actually goes in fixed wing mode. Now it is cross-tracking a bit. There's about a 10 meter per second wind that I've got set up, or 10 kilometers an hour, I think it is, the wind that I have set up in this simulation. I always like testing with a little bit of wind. Notice that it's weather vaning into the wind there automatically. Now it's flying in sideways for the last bit, so keep its nose into the wind. I like testing with a bit of wind because most people, when they fly, do have a little bit of wind, and it makes it a lot more realistic. So there it is, and now to start doing descent, it actually started climbing there because I had left the throttle stick up when I was testing from earlier, and so it meant that it actually, in this mode in QRTL, it also obeys that throttle stick, so I can pause the descent there, and I can make it go a bit left to reposition it like that, and then I can make it descend again, which means it does the same tricks as far as repositioning and pausing the descent if you enable that feature with QRTL as it does with a normal auto landing. All right, so that's the main thing, main features. Both of these new features, the delayed transition and fixed wing approach and the slow descent are optional features. The delayed transition fixed wing approach is on by default. The slowing the descent while you're landing, when the vertical part of the landing and repositioning, that is a not on by default. You've got to enable it. Now, in the actual approach code, if I switch over to a different aircraft, then you'll see another feature. So what I'm going to do is I'm going to quickly switch over here to a separate lift thrust aircraft, and I'll pick the Alti transition, and I'll just restart here. Let's just take it a second to reconnect there. All right, that's connecting, and I'll read the flight plan. I'm actually running CITL on a Linux box next door, and then I'm just using Mission Planner for my display. I'm a Linux addict. So, okay, it's actually not reset the, sorry, not reset the aircraft correctly. All right, so that is good, and slight mistake. I loaded the Griffin parameters. So I'll just go, if you'll bear with me a minute, I will now load the correct parameters for the alti transition. So it just tried to fly the transition as a tilt rotor, which is rather interesting. Produced an interesting result. All right, so now we'll reread those mission waypoints so they display correctly, and it's a slightly larger mission because the LT transition is a much bigger aircraft, much bigger radius of turn here. And you can see it's also got an early transition point, which means it'll then pick a point to slow down. So what I'm going to show you here is a subtlety in this approach code, and this is called air brake mode. And so if I go and pop it into auto mode and I arm the vehicle, then it's going to take off and then transition as just like the Griffin did. Of course, it's now transitioning using a forward motor rather than tilting the propellers because this is a separate lift and thrust vehicle. And so there it is doing its little flight around. It's a slightly larger area, and I've got the level transition option set. So notice it stayed level and straight during the forward transition, which means it didn't hit that waypoint. And so the level transition is good for aircraft where you want them to stay level and very stable during the transition. It allows you to have slightly lower transition speeds and get through the transition slightly faster, which can be good for using VTOL battery. Okay, so when this comes around, the trick that you'll see is that if we zoom in, you might be able to see it. When it'll actually go through 3 stages. It'll do the fixed wing approach, and then after the fixed wing approach, it'll then go and start the VTOL motors in what's called an air braking maneuver, where the VTOL motors are used to put drag on the aircraft to slow it down. And then after it goes through and does the air braking for a while, so it's doing the air braking and it's slowing itself down, and then it does the final transition to full VTOL. So it does the fixed wing approach, and then it does the air braking where it runs the vertical motors at low throttle just to provide some drag to slow it down. And then it finally goes into the repositioning full VTOL mode and land. And this transition drag takes advantage of the momentum drag on propellers. Momentum drag is the drag you get from your propellers when you drag them sideways through the air. It's a drag that is induced from the lift of the propellers. And that momentum drag acts in the direction, it's a drag, so it acts directly to the rear of the vehicle to slow it down, which means it's perfect. It's essentially a built-in sea anchor or air brake that will slow the aircraft down without gaining height. And that's the real trick. It means that you can you don't end up, when you're doing that back transition for your landing, gaining this enormous amount of height. You gain a lot less because the motors have slowed you down before you descend. So it's a really neat trick, and I hope you all enjoy it. And I would love to have some more testers. So if you're watching this and you have a quad plane and you're willing to run some pre-beta code, then please jump on the QuadPlane VTOL channel on the ArduPilot Discord and get involved with testing this new feature. All right, so that's all for now, and happy flying.